Okay, Assalamualaikum and good day. Alright, so today I want to record a lecture regarding the small signal frequency response. I'll be concentrating on the BJT common emitter amplifier. Okay, so in class, okay, this is the slides that we have in class, right? Okay, so we have known that that the amplifier has this type of the frequency response. Okay, this is the ideal where you have the lower and also the cutoff, the lower frequency response, and this is the higher frequency response. Okay, so we look into that for the common emitter. All right. Okay, let's see the slides that we want to go is in this page. Okay, all right. Okay, so common emitter. Okay, okay, we want to look into the low frequency response. Okay, now there are two. Okay, one is to find the lower frequency response, and the second one is the higher frequency response. Okay, just to refresh you guys again. All right, for the low cutoff frequency, this is due to the external capacitance. Capacitance. While for the high frequency is due to the internal capacitance. Okay. All right. Okay. Alright, what are the external capacitance? Okay, let's look at the slide number 8. We focus on the lower frequency response first. Okay, alright. We want to focus on the lower frequency response first. So from here we want to if you look at the circuit in these slides, okay, slide number 8, slide number 8 in your lecture notes. Okay, look at here. Okay, what are the external capacitance in this circuit? Okay, all right, we have C1, okay, C2, and also CE. So I've told you in the class already, there are two ways to find this low cutoff frequency and high cutoff frequency, but we will look into this methodology where we will find the cutoff frequency due to each capacitance at one time. Okay, all right, let's look at when we are this is the circuit. It's very hot here. Let me just redraw back here. Okay, this is RC, VCC, this is also VCC, and then you have, sorry, my drawing, RE, we have CE, okay, and then you have this, R2, and this is R1, this is C1, RS, this is VS, and then you have another capacitor here, this C2, and then you have RL to the ground, and this is your V out. Okay, and this is your V out. Okay, all right. So first, what we do is we draw the equivalent small signal circuit. Okay, when we are doing this, okay, this is the circuit that we want to build. Okay, I think here. Right. Equivalent small signal circuit of CE amplifier at low frequency band. Okay, if your questions in the exam ask you to draw this the overall small signal equivalent circuit, okay, equivalent can be here, small signal equivalent circuit, interchangeable usage of wording. Small signal equivalent circuit, the whole circuit you have to draw this one. Okay, I want you to know the whole thing. So this from here you have to transfer to the small signal equivalent circuit or this common emitter amplifier, including all the external capacitance. Okay, so this is VS, RS, this is capacitor C1, and then you have R1, and then you have R2. Okay, and then if you notice, this is your base, this is your collector, this is your emitter. So now from here, this is your base, this will be your R pi, so this is your V pi, this is your emitter. So you are using hybrid pi, GM V pi. Okay, we don't use R0 to, we do exclude R0 in our analysis here. We exclude R0. So now this is your collector. So your collector, okay, now your collector will connect to RC, C2, and this one. So how are you going to do that? So let's do here. So you connect to RC first, to the ground, and then you have capacitor C2, and then RL. This RC, RL. This is V out. At the emitter here, alright, you're going to connect this to one RE and then one CE to the ground. Okay, so this is the complete, this is the complete small signal equivalent circuit. You can, the terms here, equivalent can be here sometimes, okay? Alright, small signal equivalent circuit of the common emitter at low frequency band, the whole circuit, okay? Alright, please take note this circuit that you have to build when you are building this, okay? So it's until here because there's no R0, so we are exclude, okay? Alright, okay, now in order for us to find the low cutoff frequency, okay, so we have to consider, let's say we want to consider from this circuit, we are going to consider C1 only. Okay, let's consider C1. Why are we going to do with C2 and CE is because we are going to short it. Okay, what happened if we short CE? Do we have to consider RE? No, we don't consider RE anymore. Okay, so when it's shorted, so this is the equivalent circuit. Okay, now consider C1 only. So the equivalent circuit when considering C1 only is, so what we do is we short CE and C1. Okay, we short that one. So what we do is here, okay, now this is our VS. Okay, this is the original. Okay, can you see that? RS, C1, R1, R2, R pi. So now it's going to be directly to the ground. directly to the ground because your CE is shorted. GMV pi is your base, emitter, collector. So your RC is shorted, C2 is shorted, so this is going to be in parallel. Okay, so this is the equivalent circuit when consider C1 only. Okay, got it? Okay. Alright, then remember that in the class I already explained to you that actually we are looking for the cutoff frequency due to C1. So I have explained to you because the low cutoff frequency looks like a high pass filter, and the frequency F is the cutoff frequency as F equals to 1 over 2 pi R due to C1. Okay, in the class I already explained to you. Now, from this circuit, what we want to find is we will know C1. So what we want to do is RC1. What is RC1? RC1 is known as the Thevenin's equivalent resistance looking from C1. I have explained in the class, right, why we are looking for RC1. I hope you can revise that or ask your friend, because we already looked into the high pass filter. So from there, okay, now so from here now, all right, this part from here is like disconnected. Okay, this part is like disconnected. So what you have is, okay, when we are looking for RC1, when looking for RC1, what you do with VS is short circuit. Okay, is short circuit. Okay, not the angle here. I hope it's okay lah. Okay. So this is the equivalent. You can simplify circuit. Okay, short RS to the ground, C1. So I will put a resistor here, which is R1 parallel to R2 parallel to R pi. Okay, so therefore resistance RC1, okay, looking from there is, therefore RC1 equals to RS, okay, plus or parallel, because this is actually connected or grounded. From here it is RS, what with R1 parallel R2 parallel R pi, plus or parallel. Okay, I already explained in the class, it is in series, is plus. Okay, therefore FC1 is equals to 1 over 2 pi RS plus R1 parallel R2 parallel R pi close C1. Okay, so this is your final answer for the FC1. Okay, alright, I think I have to pause now. It's 40 minutes. If I do it both, then it will be longer. Let's stop here. It will continue to find the capacity, the low cutoff frequency due to C2 and CE later. Alright, okay.